Welcome viewers, in this video we will see the implementation of Boolean function using the multiplexer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we will go to the topic. We need to implement the following Boolean function using 8:1 multiplexer. The given function is f of a b c d equal to a bar b d bar plus a c d plus b bar c d plus a bar c bar d, right? 1 2 3 4 4 terms are available. Also the variables are 4 variables a b c d, but this given Boolean function is not in a standard form. Standard form means every term contain all 4 variables a b c d, but this first term contain a b and d. C is missing here, b is missing, here a is missing, here b is missing, right? So the standard form means every term contain all 4 variables. So it is not in a standard form. So we need to bring the follow given Boolean function into the standard form. How to make it in the standard form? So this is the given Boolean function. A bar b d bar is the first term. Here c is missing, so that multiplied with c plus c bar. What is the value of c plus c bar? C plus c bar is 1. So the original value will not affect. Similarly, the second term is ACD. Here b is missing, so multiply with b plus b bar. So third term is b bar CD. The a is missing, so multiplied with a plus a bar. Fourth term is a bar c bar d. The b is missing, so multiplied with b plus b bar. Now multiply inside, right? A bar b bar d bar into c. Similarly, a bar b bar d bar into c bar. Similarly here a b c d, a b bar c d, a b bar c d, a bar b bar c d, a b c bar d, a b bar c bar d, right? So all terms are multiplied inside, right? So in this a bar b bar c d is written a b bar c d, a b c d, a bar b bar c, a bar b bar c d, right? So a b bar c d is available 2 times. This is available 2 times, so it is written only 1 time. A bar b bar c d, a b c c bar d, a bar b c bar d, a bar b bar c bar d, right? 1 2 3 4 5 6 7 8 terms available. So this term is repeated, a b bar c d, so it written only 1 time, so it becomes 7. 1 2 3 4 5 6 7 terms are now available. Now we need to find the min term, the sum of min term, so that it is easy to implement with the Boolean function, right? So it is by using the weightage 8 4 2 1 we can find the value 0 1 1 0. Here 0 1 1 0 mean 2 4 plus 2 6. 0 1 0 0, only the second term is 1. Second term means 4. All terms are 1. So 8 plus 4 12, 12 plus 4 14, 14 plus 1 15. A is 1 0 1 1. Only second term is 0, remaining terms are 1. So the second term is 0. So 8 plus 2 10, 10 plus 1 11. Then a bar b bar c d, only the third and fourth term is 1, that is 2 plus 1 3. A 0 1 0 1, right? Second and fourth terms are 1. Second term is 4, last term is 1. So 4 plus 1 5. 0 0 0 1, only last term is 1. Last term is 1, right? So we can find the min term value by using the weightage 8 4 2 1. So this is 8 6 4 15 11 3 5 and 1. Now it is written in a order. Given Boolean function f of a b c d equal to sum of min term 1 comma 3 comma 4 comma 5 comma 6 comma 11 comma 15. It's 7 terms available. 1 2 3 4 5 6 7 terms are available. Now we need to decide the what are the selection lines and what is the implementation table. So there are 4 inputs available a b c d. In that the least significant bits, that is D, C and B, is assigned as a selection line. D is assigned as S0, C is assigned to S1, B is assigned to S2. Then A is the deciding factor. Out of 4 input, 3 are assigned as a selection lines. D, C and B is assigned as S0, S1 and S2. Right. By using this, we have to implement the implementation table. Right. So, the A is the deciding factor. There are 8 inputs available to the multiplexer. It is a 8:1 multiplexer. D0, D1 up to D7 available. Right. So, there are 16 combinations from 0 to 15. Right. 4 variables are there, A, B, C, D. So, there is a 16 possibilities available. Start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Right. So, this is the deciding factor. This is the input to the multiplexer. These are all the 16 possible decimal numbers. Right. Now, we need to mark what are the terms available in the Boolean function. We need to circle. Right. 1 is available, 3, 4, 5, 6, 11 and 15. These are all given in the Boolean function. So, that are all encircled. Now, we need to inspect the every column. The first column, no circle is available. So, it is 0. Here, the first column, first row is encircled. This is encircled. What is available in the corresponding input as A bar. Here, no circles are available. So, it is 0. If both are circled, then the input is 1. Right? Both are encircled means 1. Both are not circled means 0. Any one is circled means corresponding value as a input. So, here in the 4, 5, 6, in the 3 column, the top is encircled. What is the corresponding A bar? So, the A bar is the input for D4, D5 and D6. For D7, this bottom is encircled. So, what is the corresponding input? A. Right. So, now we decided the input to the multiplexer. D0 is 0, D1 is A bar, D2 is 0, D3 is 1, D4, D5, D6 is A bar, D7 is A. Now, we can implement this input to the, we will go to the logic diagram. So, this is the 8:1 multiplexer. The 3 selection lines are available, S2, S1 and S0. So, D is assigned as S0 and C is assigned as S1, B is assigned as S2. Right. The A is the deciding factor. In a Boolean function, A, B, C, D is given. A is the deciding factor. B, C is assigned as a selection line. Then the 8 inputs are available. D0, D1 to D7. These 8 inputs are we decided from the implementation table. Right. The D0 is 0. D1 is A bar. D2 also 0. D3 is 1. D4, D5, D6 is nothing but A bar. D7 is A. Right. So, all the values are assigned. I will repeat again. D0 is 0, D1 is A bar, D2 is 0, D3 is 1, D4, D5, D6 is A bar, D7 is A. Right. Now, based on the selection line, any one of the input is available at the output. Right. For example, this is 3 variable, 8 combinations are available, 0, 0, 0, 0, 0, 1 like that. 0, 0, 0 means D1 will be available. 0, 0, 1 means 0, 0, 0 means D0 will be available. 0, 0, 1 means D1 will be available. Now, we will see whether this mux will produce our required Boolean function. What is our required Boolean function output? What we need? 1, 3, 4, 5, 6, 11 and 15. These 7 functions should be produced by this multiplexer. We will see whether we will verify that. Right. So, BCD is the selection line, S0, S1, S2. This is the output. This is the deciding factor A, that can be taken as S3. First, we will see the first combination 0, 0, 0. If the selection line is 0, 0 means what is available? D0 is available at the output. What is D0? D0 is 0. So, this is not our required output. The second combination 0, 0, 1. Right. Then D1 will be available at the output. What is D1? D1 is A0. Right. D1 is A0. What is the value of A? We don't know the value of A. A may be 0 or 1. In order to produce here 1, if the A is 0, A0 will be automatically 1. Right. So, we will take A equal to 0. While A equal to 0, A bar equal to 1. That means the multiplexer is producing the output. What is the output? 0, 0, 1. 0, 0, 1 means it is equivalent to 1. right? So that 1 is available, 1 is what we required. So this output is covered, right? So the first output is covered, right? We'll go to the third combination, 0 1 0. 0 1 0 means it will give the D2. What is the D2 value? It is 0. So the output of the mux is 0, right? Now we'll go to the fourth combination, 0 1 1. 0 1 1 means it will produce D3. D3 is nothing but 1. D3 is 1. Then what is the value of A? The A value may be 0 or 1. In both the cases it will produce 1, right? Irrespective of A value. So we can take both the values, 0 0 1 1, 1 0 1 1, right? In both the cases the output is 1. The mux is producing the output, right? So that A can be 0 or A may be 1. 0 0 1 1 means it is equivalent to 3, right? 1 0 1 1 means it is equivalent to 11, that is 8 4 2 1. 8 plus 4 is 0, so 8 plus 2 plus 1 is 11. Now 3 and 11 is covered, so this is the 3 is covered and 11 also covered, right? Then we'll go to the next combination, the fifth one, 1 0 0. 1 0 0 means the D4 will be produced at the output. What is the D4? D4 is A0. D4 is A0. For other three combination, A0 is the output. 1 0 0, 1 0 1, 1 1 0. In that all three cases, A0 is the output. See, that's connected. D4, D5, D6 is connected as A bar. Right. What is the A bar value? If A is 0, A bar will be 1. So the mux is producing the output. Here also same thing. So previously also we discussed. If A equal to 1, the A bar will become 0. There is no output. In order to produce the output here, we will assume that the A is 0 in all three cases. So in all three cases, A0 is there. A0 means 1. So these three outputs are available. What is the corresponding input? 0 1 0 0. It means the value is 4. 0 1 0 1. The value is 5. 0 1 1 0. Value is 6. That is 8 4 2 1. 4 plus 2 6. 8 4 2 1. 4 plus 1 5. 8 4 2 1. 4 is available. So 4 5 6 is now available. So this covered. 4 5 6 is now covered. Right. See the next one. The last combination is 1 1 1. The last one is the 1 1 1. What is the 1 1 1? What is the output? D7. What is D7? A. A is the value, right? A. The output should be 1 mean A should be 1. If it is 0, output also 0. So we'll take this is 1. So what is this value? 1 1 1 1. 8 4 2 1. 8 plus 4 12. 12 plus 2 14. 14 plus 1 15. See this now 15 also covered. See this all 7 outputs are covered. That is this multiplexer producing our required 7 outputs, 1 3 4 5 6 11 and 15. So by analyzing this input, analyzing the output, we verified that this mux is producing our required Boolean function, right? So this is fully based on when the selection line is 0 0 mean D0 will be available. 0 0 1 mean D1 will be available. So that is analyzed. We verified that it is producing the required Boolean function. Similarly, we need to decide what is the input to this multiplexer D0 to D7. That is based on the implementation table. So in this video, we discuss the implementation of Boolean function using the multiplexer. The given function is implemented with the multiplexer. First, we decided the selection line. Out of 4 inputs, 3 is assigned as a selection line, 4th one is taken as a deciding input. That is MSB is the deciding input. LSB, start from LSB, 3 values are assigned as selection line. Then we calculated the input to the 8 input to the multiplexer using implementation table. Then by using that, the multiplexer is designed and we verified the output whether this multiplexer is producing our required Boolean function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.